Breathing City seminar for this week. I'm Henry Burridge, and I will simply be chairing today. And I very much want to thank Nathan Wood for agreeing to present to us. And I think I will start by saying that, you know, Nathan is the managing director of Farmwood, which is an SME specializing in supplying ventilation solutions for buildings. My reading of Nathan is that what he's going to talk about today is really inspired by his work, but perhaps almost not really part of his work, in the sense that he seems to have got quite concerned about the state of air handling and ventilation in the buildings he was experienced. And rather than seeing that solely as a business opportunity, he's really tried to make a difference to people beyond his customer base. I think that's a really laudable thing. And you know, two notable examples of that are that Nathan is now the chairman of the Health and Wellbeing in Buildings panel for the Building Engineering Services Association, BESA. And Nathan was also a really strong driving force in the launching of World Ventilation Day in November last year. So without further ado, I will hand over to Nathan.
Thank you, Henry. Hi, everybody. Thanks for your time today. Let's just share my screen to get things started. There we go. There. Hopefully you can see the screen there. So thanks for the opportunity and welcome, everybody. I'm going to walk you through some slides, very honest slides, and the title I hope follows the theme in terms of ventilation, the Cinderella industry through the eyes of a ventilation engineer. So a little bit about me. My name's Nathan Wood, managing director of a fabulous company called Farmwood. My father started the business over 21 years ago. And since birth, we've specialised in all aspects of ventilation systems, from commercial through to residential. I originally trained as a multi-skilled engineer at a local steel foundry, and what I know about air quality now, I should never have stepped foot in the place, but that's for another time. Where I learned about electrical, mechanical, fabrication. I joined my father following the closure of the plant, and initially it was literally myself and my father with the business. Covering the south, most of London. We've organically grown over 21 years of business, which is fantastic. And the team is now 36 amazing, awesome people. I owe a lot of thanks to my son, my youngest son, Rory, for an opportune development into the world of air quality almost 8 years ago. I was being a good father, taking in turns with the night feeds, attempting to multitask. And I found myself completing the LinkedIn profile. And the days and weeks that followed, I connected with everybody that was talking about HVAC or air quality or ventilation. Some people, mainly overseas, were talking about this thing called IAQ, which at the time I had no idea what it stood for, but indeed it was indoor air quality. I found myself being absolutely fascinated by the relationship of what we were doing as a company for all these years without making the connection to the very human beings within the buildings that we was looking after. I mean, since we've been called the physicians of buildings, which does make a lot of sense, but we rarely made the connection between what we did and the inhabitants back then. So with the light bulb glowing, we began working with all different types of technologies, systems from purifiers, indoor air quality monitors, speaking with anybody and everybody, and like an excited puppy, as they call me here, I vividly remember calling the team to a meeting to discuss how we're going to do this crash course in IAQ and the need to develop a real ground grounding and a hone-in for our skill set within air quality. And then literally an opportunity landed on our doorstep. The BBC had planned a DIY SOS Big Build. So again, excited puppy kicked in. Let's crack on and let's do this. So we quickly worked on a design for a whole house ventilation system, an MVHR system with integrated, probably what was one of the first IoT monitors, so that the system would automatically boost when the pollution levels were exceeding the limits determined by this air quality monitor. So the plans were set. We met with the BBC team, showcased what we was offering them, and they just turned it down. It's too complicated. We don't need it. No one's doing this. It's going to cause problems with the build. No, thank you. Not one to back down. Politely, we highlighted the importance of clean air ventilation. It would probably be a UK first back then. This seemed to get their attention. We got the stamp of approval, but we was told if we hold up any other trades, they would literally stop us, kick us off site and carry on with the basics. The project really was amazing. I'd recommend to anybody that gets the opportunity to get involved with any scheme like this, any development or show. It doesn't have to be a show. I mean, we do lots of other stuff that we don't talk about, but this was an amazing insight into what we could do. So you see in the picture, there's Nick Knowles, which most of you know, and then there's Gary Kyle, who adopted Hayden, Curtis, Bella and Phoebe, vulnerable kids with complex special needs. And Curtis in the blue jumper there, he was routinely hospitalized with respiratory issues through the changing seasons in the old building. It's been 7 years since we've installed this system for them. We maintain it very, very regular, more than what the manufacturers recommend. And his health has improved year on year, and he wasn't hospitalized through these seasonal issues since. All the family have developed. We've become very good friends. So was it the air quality? Was it the new home? Or were the children just maturing again better? Who knows? But we know one thing, that when they're at home, they're breathing much, much cleaner air than there was before. So that was my insight into the world of ventilation and air quality. So when we talk about ventilation, or when I talk about ventilation, most people assume what you see on the screen now. You've got this lovely spacious installation, predetermined by CAD drawings or 3D renders of ducted systems throughout the property. For what I'm going to talk to you and showcase going forward, this is so far removed from the truth of what we have been dealing with over the last 21 years, but indeed the photos that I've selected are probably all taken within the last 2 to 3 months. There are rules and regulations and guidance galore for ventilation systems. There's expert guidance from manufacturers, installation manuals, I&M manuals, that bit of paper that nobody ever seems to read. Regulations in approved documents, approved document F for ventilation, recently undergone sort of the biggest revision for quite some time. It's fantastic to see that air quality is included in this guidance. Doesn't go far enough for my liking, but it's an improvement, and every little step helps as we go through. There's a specific residential training course that was developed in 2016 with the idea of developing a new wave of quality installations, and also touched on indoor air quality. That was back in 2016. It's only a 2-day course, so pretty much anybody, the criteria to get on the course is quite loose, can go on a 2-day course, and then after 2 days you're deemed competent to install residential systems from design to install to commission. So you get your certificate, and then a few days later, a few weeks later, or you could find yourself working on a big development of apartments or flats for say 200 MVHR systems, commissioning them off sign and off the building control, which I think is absolutely ludicrous. but it still happens to this day. People deem themselves competent. They win these jobs. They do the installations, and to sign off an MVHR system, the property needs to be like 100% finished. So carpets fitted, doors hung, windows fitted, kitchen in place, toilets and bathrooms, tiles and everything else. So at that stage, in theory, they're marking their own homework. You know, you can't actually prove that the system is going to work until everything's done. I mean, I still find it strange that we have a whole house ventilation system that still relies on the undercut of a door from a completely different trade who may or may not know about the requirements for the undercut. More often than not, what we find these days is that people like the threshold underneath the door to be as neat and as tight as possible. They don't want these big chunky undercuts. So at that stage, if they're commissioning the airflow with their anemometer, and indeed they find that they're a few litres of air off of the minimum flow rate requirement set out in approved document F, are they going to go back and say, right, we need to not hand this over? Are we going to take down the ceiling, investigate the ducting, check out the ventilation unit, make sure it's performing properly? Or are they just going to mark down those few extra litres that they need to make the commissioning sheet approved and to sign over and hand over the property? Because it's intangible, right? No one's going to pick up on it. No one's going to complain. It's not like a light switch that you turn on and a light bulb flickers or it doesn't work, or a tap that drips water or no water comes out at all. So what we quite often find is it's not until the residents have moved in and been in there for quite some period of time that they complain of headaches or there's excuse me, the development of mold or damp within the property. So as I follow through the presentation, all of the photos used, as I said, are recent photos shared from my team. These are not library photos. It's a bit of an insight, hopefully, into the darker side of the industry. The forgotten ones, the misused and the mistreated, in essence, of the Cinderella industry. So it might be a bit hard to depict on here, but this is the internals of a mechanical ventilation heat recovery system, MVHR, that was isolated in a social housing property due to void works being carried out before the new people moved in. And we was asked by the social housing company to go in, check over the ventilation system, give it a clean bill of health, make sure that the airflows are okay, ready for them to move in. When ventilation systems within a house are turned off, it doesn't take long for condensation to form in different chambers within the system that's not designed to. And without the fans operating, the airflow is quite stagnant. And you can see from this picture, this actually happened within 3 months of the unit being switched off, people being moved out and works being undertaken. And in the center there, the black section, that is actually black mold that when was wiped away was sticky. So, you know, and then you've got all of the white contaminants and dust that have built up on the impeller blades. So had we have just been there, take the filters out, pop new filters back in, turn it on and check it, chances are it wouldn't have worked. But if it did, nobody would have been none the wiser about that black mold sitting within that unit. Sorry for this one. Sorry if you're squeamish. This was some kind of fungus or bacteria build-up within the unit that our engineers found sitting in the corner of the tray at the bottom of another MVHR system. It's gross. This should not be in a system that pushes air around our home that we breathe in. This is not a slice of toast. This is actually another MVHR filter. Clearly heavily deposited with fat and grease, probably where the extract point within the kitchen has been located too close to the hob, or indeed that there was no kitchen canopy installed at all, and the unit hasn't been serviced for any period of time. So clearly, if that's the condition of the filter, all of the ducting from the kitchen all the way through to that unit will be heavily contaminated with deposits. This is another London Council property, whereby we was asked to go in and change the cream unit at the bottom there, another heat recovery unit. We put in a quotation that said that the ducting needed upgrading and changing, and the report came back. The email came back from the council saying, sorry, no, we just want the unit changed. Thank you very much. Yet this was the condition of the ducting above the unit, and the unit was extremely old. So I don't know why they assumed that the ventilation would be okay as well. But it's not just old historic units. This is a brand new installation, a system that we was asked to go in and commission. So you've got a mixture of semi-rigid aluminium ducting and then this awful local wholesaler plastic ducting. And in the regulations, it states you are allowed to use flexible ducting up to a maximum of 300 mil, so long as the ducting is pulled tight and taut. Now, usually this is initially as it comes off of the unit, or indeed by the air valves within the ceilings. But this is what somebody deemed competent, thought was adequate for the ventilation system, and couldn't understand why we wouldn't continue to certify and sign off the system. But at least they went as far as to denote what ducting was to supply and extract with their electrical tape. Not quite sure what the black stuff's about. So that's a new build. And also, if you notice up in the top right hand corner, the fuse spurs were switched on and yet not secured back to the mattresses behind. Furthermore, in ducted systems, ventilation hygiene comes into play, and compartmentation in terms of fire spread. The valve that you can see internally on that picture is a butterfly valve that should spring open in the event of a fire. It's got a little fuse link inside of it. That should flip open, close off the valve, and not allow the spread of fire through. But this fine particulate and dust, it's normally fine tissue fibers, which are extremely flammable. So if this was to activate, which I doubt, the chances are that the fire would have spread straight through that ducting anyway, without any hesitation at all. Apologies, another gross photo. This one's the back of the air valves, so the circular air valves or punker valves that fit into the ceiling of ventilation systems. This one was removed from the back of a kitchen canopy hood, near the back of a kitchen canopy hood, sorry. So again, what you saw with that piece of toast filter earlier, these are the conditions that are within the air valve itself. And you've got to think, if they're collecting here, all of these tiny deposits of grease are in the air that the occupants within that space are breathing. So if they lived in the property, as long as that air valve was there, chances are these deposits are entering their body and doing all sorts of harm as well. This is a good one, a lovely retrofit. Looks pretty cool to the untrained eye. This was signed off. Social housing development in London. The kitchen was removed, new kitchen fitted. Part of the requirements was to retrofit in a kitchen canopy hood, which they've done. Unfortunately, they thought the right idea was to actually duct that through to the existing MVHR ceiling air valve in the top, and they've actually plastered in some of that duct as well, that rectangular duct. And when it was removed, that's what we found inside it. Again, it should not be connected. You can recirculate with carbon filtration. I don't recommend that. It should have, a kitchen canopy should have its own extract through to outside, completely separate from the heat recovery system. So again, heavily contaminated. The ducting needs removing. To remove the ducting, you've got to remove the ceiling. It's one hell of a task. More often than not, the resident has to be moved out. So just through somebody thinking they're doing the right thing, it's actually caused quite a problem. This was a fan that we was called out to, whereby report was that the unit was hanging out the ceiling. It was. It fell out the ceiling because they'd used wood screws straight into plasterboard, and I think it was 3 out of the 4 fixings were fitted into that anyway. It was still on and operational, and when we checked inside the ceiling, it was never going to connect through to the ducts above it anyway. So it was just blowing the warm, moist air into the ceiling cavity around the top of the bathroom. This is a great example. So this was a home builder, self-developer, called us in to commission their system because they couldn't sign it off themselves. The majority of the system was pretty good. It was okay. I very much doubt that on the 3D CAD drawings that we saw at the beginning, it showed a piece of flex popping over the top of an existing duct. So this is one duct going from left to right, and then the duct coming in from the right to the left should go over the top nice and smoothly. That one connection there resulted in the system not passing. As we investigated and found out, requiring the ceiling to be cut and made good, that's what it should have been. Lovely swept dogleg connection. So that's the before, that's the after. That is a fail. That's enough to get a pass. Because again, ventilation systems are designed to minimum requirements. People size the units accordingly. The slightest issue in installation can be a fail. It can result in poor indoor air quality, mold and condensation, noisy units, units running faster than they have to. So something as simple as that one section was a fail. Or we could have left it like that and just put a few extra litres of air, but that's not us. Off-site manufacturing, huge champion of off-site manufacturing. It is the future, I think. There's lots of people doing it, some very successfully, this one not so. This is a off-site pre-manufactured pod whereby you've got the heat exchanger unit here in the white frame. Underneath it, you might be able to make out there's a Wilex electrical distribution board set right underneath it. Further down, there was a washing machine, and to the left-hand side, there was an expansion vessel. So there was no way of dropping the unit or moving it to the left. Unfortunately, once it's put in position and the door frame's fitted, you can't remove the green heat exchanger from the unit. If you can't remove the green heat exchanger, you can't access the fans, you can't access the PCBs, so you cannot service that unit. Therefore, there's no warranty if there was anything to go wrong, and you can't physically drop the unit without removing either the distribution board or the expansion vessel. So again, more joined up thinking is needed with this off-site manufacture once it lands on site, because this system wouldn't have flagged up as being a problem initially. I very much doubt that anybody on site would say, right, let's remove that cover and make sure that the internals can come out. They could seal it, you could get to the frame, remove the front cover and assume that that is adequate for maintenance. The I&M that would have been supplied with that unit would have clearly stated the minimum distance requirement from the front of the MVHR all the way out to allow for adequate maintenance. This is a lovely photo sent in by one of our engineers. This was an installation that we improved for a client. Unfortunately, they didn't get the before photo, but it was lots of flexible ducts coming off the top of the units. However, as good as this looks, this doesn't actually comply with the manufacturer's I&M. The first horizontal duct section that you see connected doesn't allow for 300 mil straight rigid duct off the top of the unit. But we couldn't go any higher because of the joist setup, and we couldn't go any lower because the requirement for a HEPFO dry trap and enough fall on the condensate. So that looks pretty good. You know, it needs some extra brackets and fittings, but yeah, you know, but even that doesn't actually tick the requirements that the manufacturer sets out. However, it is accessible. The airflows were fantastic. The noise was very low and it ran at a nice low speed. But it's not just residential systems. This is a baffle section from the internals of a communal bathroom extract system at a high-rise block of flats in Chelsea. The condition and the dust and the deposits on that baffle that's been drawn up from inside, it doesn't take an expert to understand that the ducting is heavily contaminated, never been maintained, never been cleaned, and yet for years there have been planned preventative maintenance checks carried out on this system by lots of previous contractors, and it's just been a tick box exercise. It needs to be addressed. The next photo was from the ducting that led down from that system, as you can see, heavily deposited. This stuff is extremely flammable. This is a larger air handling unit commercial system, and again, through poor maintenance, the filter has got so contaminated that it has actually collapsed inside of the housing, allowing all of the contaminants to come through onto the white section of the coil above pier. So it's not just a case of changing the filters now. This unit, you can't actually get through between the filter section on the left and the fan coil, sorry, the coil on the right-hand side. So we've now got to split apart the air handling unit to physically get in there to carry out a deep clean of the coil. We can't remove the coil because of the obstructions within the plant room. So poor maintenance costs so much more in the long run, let alone efficiencies of the system. And this is very, very commonplace. This is a pretty gross one as well. So this is another communal extract unit. You can see all of the white, I don't know what it is, mold, fungus deposits building up inside the units. Unfortunately, when you've got a lovely metal sheet metal unit sat on top of a roof that fails or is turned off, it doesn't take long for condensation and mold to build up within these systems. We get called along to just turn them back on or find out what's wrong and give them a clean bill of health. But you need to take into account the conditions that can quickly generate within that. Without taking the lid off, you might have just turned the isolator off, turned it back on again. It fires up and working, great, tick the box, move along. Take the cover off, it's a completely different story. That's assuming that there was a cover fitted in the first place. So this is a really old system. These fans are probably 25, 30 years old. Really old system. It's been modified by somebody thinking they're doing the right thing by wiring in that white junction box, but by installing it at the back of the fans, they're restricting the chamber to this one fan here. This one was probably failed long before it. These are normally a duty share fan, so this one's just been doing all of the work. It's clear to see that the lid's been lost or removed at some stage. Something's been silicon sealed over the top of it. You can see there's silicon being used around the top, which would prevent future maintenance anyway. It's extremely hard to remove steel joints, plates with silicon. And just look at the water that's built up inside. So that would be building up, running down the internal ducts through into the properties below. Damp and mold would form really quickly in all sorts of places within the internal fabric of that building that you just will not see until it penetrates through to the fabric of the building. Furthermore, within communal ventilated systems, there's fire safety. I've shown you the butterfly valve previously. This isn't a little beehive as it looks. It's actually an intramescent fire block. This fire block is probably 45, 50 years old. These should be annually inspected and changed as and when required by the manufacturers. This is a much older size. You can get replacements, but they're more often than not a bespoke size. And you have to order huge quantities to get any decent pricing. So it's really hard to remove these sections, update them. You normally have to change out to a fire-rated air valve with a snapshot fusible link within the property. That requires a pattress, fire protection surround, but it's really important that any system that you install meets the manufacturer's installation data. You cannot deviate in any way, shape or form from that. If we do move forward with this project, I want to find out if we can actually reuse these for insects or something, because that looks like it should be mounted to the outside of a building somewhere and encouraging insects. The next slide shows a refurbished building. So this is again a London property. Solar panels, the roof was removed, new insulated roof put on, new felting, new cladding on the outside of the building with new windows, and yet the existing communal extract system was left with a kicked-in grill and damaged ducting and just loads of silver tape onto the top. How that wasn't part of the tender to upgrade the whole system, I don't know. They eventually realised that there was a problem when mould and condensation quickly formed within the properties because the older building was traditionally leaky. The air would, pass between the cracks and the nooks and the old windows. It wasn't thermally insulated. So if we're looking at retrofitting our buildings, making them, super efficient energy ratings, it's great. They've taken the initiative with solar, with insulating the roof and cladding the building with new windows and new entry doors and everything else. They omitted the ventilation, which is quite often, I always comment on people's articles or LinkedIn posts whereby they talk about insulation and you say, insulate tight, ventilate right. There's other rhymes that go with that as well, but it's certainly true. The solution here was a much bigger system. Bigfoot system ducted through onto the existing duct. The ducting was cleaned internally. a brand new twin fan extract system that could extract much higher rates than what was required previously, because when the building was probably first designed, people didn't have power showers, they didn't have multiple over occupancy or multiple occupancy. So this is able to handle much better flows. Internally, the ducting was cleaned from the apartment and from the main risers, and as I mentioned, the fire rated air valves were put on there. So what we do on roofs, tinkering, changing stuff, not ticking boxes for PPM checks, there is a human element to it. Sadly, these faces are probably very familiar to people. Young Ella passed away as a result of air pollution causing severe asthma attack relating to spikes in outdoor air pollution. Young Awab passed away due to extreme mold and damp within his property. What we do in buildings has a direct effect on the health and well-being of everybody inside them. So we need the value of what ventilation is to be given its own right. Far too often, ventilation tenders for social housing, councils, different blocks, offices, schools, the ventilation gets lumped in with the heating and the gas. They are completely two separate trades and should be treated as such, because anybody that's looking at a tender will probably be a heating company that might do a little bit of ventilation. Are they competent in what they're doing? Do they know what they're doing, or is it just a tick box exercise? Because it was probably a tick box exercise that cost these young people their lives. I mean, it's vital that we start to do more to understand that. As Henry mentioned, I was extremely overwhelmed and privileged to be involved in World Ventilate Day, which was a huge success. We are carrying that forward, and it's got global attention, which is fantastic. But there's so many people talking about air quality within our buildings. They've been talking about it for years. You look back to the smog in London of the 1950s, 1952. We've known about it for years. I fell in the trap of researching the history of air pollution. We've known about everything we talk about for years. It's just that medical science has improved to such a level now that even though the smog has reduced and the days look clearer, you've only got to remember back when lockdown happened. You know, you could see fish in the water of Venice. The London air pollution smog dropped. You know, people said that they could smell flowers that they could never smell before, and yet we seem to have just gone back to everything as normal. We've got the chief scientific officer telling us we've got to do more. Technology is there. There's air quality monitoring, there's purifiers, there's increased ventilation systems, there's loads of different systems and pathways that we can do, but we need something to enforce it. Ventilation manufacturers will do more if there is a standard or a specification for them to do more, and currently that's lacking. There is a huge thing on the horizon. Sorry, job 2. The Building Safety Act. This is going to really put the brakes on for some businesses. I see ourselves as this nimble speedboat. We're not a big oil tanker like the big boys that take ages to change direction. We're already on this. We're already issuing non-conformance notices to the people responsible for the buildings for those photos that we've seen, saying you do not comply. This is now a digital record. Sending an email isn't good enough. Bringing them up and telling them isn't good enough. You need a log to say you're not conforming. We're telling you you're not conforming. You've got 14 days to respond to this. If not, we're going to have to report you to the HSE or the building safety regulator, the appointed people. So this is a huge change. Judith Hackett has been instrumental, and I've been to a few of her seminars. I'd recommend, if you're not aware of this, jump on it now. It's something that we're talking about almost daily. But again, it comes back to people within buildings, health and well-being, and the cost of life. Please get behind Ella's Law if you're not already. Have a look into that. That'd be fantastic. Thank you very much for listening. Hopefully I've left time for some Q&A. Scan the code there to get me on LinkedIn, and we can carry on the conversation. But that's all for me. Thank you very much.
Thank you, Nathan. That was a really interesting and inspiring talk, actually. Please if you've got questions, just raise your hand digitally or type them into the chat. I do have a question, Nathan. You, and I might have misunderstood. I totally agree that ventilation, is definitely as important as heating. You seem to suggest that we should manage the heating provision and the ventilation, or the supply of the heating provision and the ventilation provision somewhat separately. And I just wondered, was I right in my understanding on that? And because to my mind, ventilation has such the ventilation solution has such a big impact on the heating need, and I don't know quite how that would practically work separating them.
The trouble that we come across is that we subcontract out to the bigger companies that are able to go after the big tender packages, where the ventilation is lumped in with the heating and the gas. They have skilled trained gas and heating engineers, and they try to use them to cover the ventilation, where it just ends up being this tick box exercise, as I showed in the images before. They then fall foul where people start to complain of mold and damp. And now, because of the Building Safety Act, there is a requirement for people that you use to be competent. So there's a cascade of information that follows down. You can't just say, well, I use this guy, he told me he was good. You need to ensure that your teams that you're using are competent. We then go in, look at the systems and say, what's been going on with this? Speak to the heating engineer, and he goes, oh, I don't know, I was just told to get it running. Now that's like us going to a boiler and saying, is it working or not? It's two different trades. We should be working in harmony, and there is definitely a crossover in the regulation, but they're so short-sighted. There's some amazing sites in London that are crying out for commercial heat recovery systems to be dropped onto the roof of council blocks, where you can recover that waste heat energy that's coming out from the bathrooms. You can temper the supply air coming back in, raise the core temperature of the building by a few degrees, that will offer huge savings for the residents within those homes. It's a council-owned block. The council approve what goes on the roof, and yet they can't be bothered, which is the truth of it, to deal with the paperwork that would allow something like that to happen. So we're just asked to upgrade the systems that are there like for like. It's very, very short-sighted. But we've got these targets, 2030, 2050, something like 80% of our existing housing stock must be upgraded by 2050, because it's still going to be in use by 2050. I just don't see any change just yet.
Yeah. Okay, thank you. That was very clear. Richard Daniels has a question in the chat. I think, is it Richard? Do you want to unmute yourself? Is that just specific to one image you're asking, or?
No, I think what I find is there's a big shortage of access ducts for cleaning. I look at schools quite a lot, but I'm pretty shocked. I always have been about this wire wound ductwork that people think is good enough, and I don't think you can put an access duct into it really. What it is you have to strip it out and put new in, is the maintenance regime for that stuff.
Yeah, depending on the construction of the spiral, you can actually cut it out and fit access hatches in, but then there's issues with hot works and what nibblers you're using and what contamination the cutting process will actually put into the duct. But there's regulations, TR19 and various other organisations that put systems through that stipulate the requirement of duct cleaning and duct hygiene. Unfortunately, it's only normally insurers that would get involved, that would ask for this certification to prove that you are indeed covering the competence of what needs to be carried out. Because you can't get machinery and rotary brushes and everything else in for long sections. We've actually developed our own, that sounds posh, we've done a Blue Peter 360 CCTV camera that we can drop down up to 50, 60 meters. And it's clear that the cleaning companies that these places are using only have 20 meters of brush. Because once you get past that point, it's unbelievable.
I see. So you're mostly concerned about domestic, I expect. And I'm mostly in schools, but it's not just the vent which is a problem. I think all the M&E, it can be value engineered, and
you're right.
We've got to get our processes better.
I mean, with schools, they haven't got the money for basic facilities, pens, pencils, rubbers, rulers sometimes. But and when you talk to them about ventilation, especially whereby you might have had an old school that's moved across to a new academy, you've got the same, if I can call them caretakers or facilities managers, whatever they need to be called these days. Suddenly they're met with inverter controls and everything else, whereas before they had that handover switch that they would do every Tuesday, and they knew the routine of it. So we need to upskill people as we upgrade these buildings as well.
Yeah.
Excellent. Thank you, Nathan. Simon Corby, do you just want to unmute yourself? That's an interesting question.
Yeah, so thanks. Yeah, hi, Nathan. Really impressive set of slides. Quite scary, I have to say. You know, I always think that I'm not shocked, but I was then shocked. Thank you for that. Ian Mordett did a little bit of work, I think, looking back in something like 2012 or 2016 at Part F assessments on MVHR, and found the vast majority of them probably would fail an installation certificate. And I'm just sort of wondering, has that got better? So how often do you go into a building and go, this is amazing, I'm going to eat my dinner off it?
Rarely is
No,
the
okay.
honest answer. So we do a lot of independent commissioning for people, and I do think that we're going to start and follow suit. I think in Ireland there's a requirement that you can't mark your own homework, and you have to use independent commissioning companies to go in and verify it.
Okay.
So, and like I say, it's too easy for somebody to go 8 litres, next, move on. I mean, we've seen photocopied certificates for whole blocks, like for like, handed in. Building control, I could be careful now. The ones that we've come across,
Yeah.
don't even know what a rotating vane anemometer is. I mean, we've gone to one place, they bought an anemometer off of an online shopping centre and used a small traffic cone as the hood.
Okay.
And we're trying to commission. That still happens. Even a lovely development, massive development that without question you'd have all seen on TV at one time or another. And the architect decided to use lovely linear slots in the bathroom that you can't commission, and the volume control damper was above the ceiling that was plastered in. So when we failed the systems, we were then cutting out the ceilings of multi-million-pound apartments to get to the volume control dampers to set them up. And the developer won awards for it.
Yeah,
so it's not all as it seems.
So would you say that maybe, you know, less than half are really
Yes.
up to scratch? Really?
Yeah. And again, it's
Mm.
because we design to an absolute minimum, there's no margin for error. I mean, we get asked to commission systems where we're running them at like 90% of their duty. They go, yeah, but that's fine. That's got the pass rate. And like, but they're not designed for that. You wouldn't drive your car in first gear on 60 mile an hour on the motorway, but that's what you're expecting these systems to do.
Yeah. Okay. So what do you think the way of improving the quality of installation is? Is there a quick fix?
Yes, we need to install them correctly. I think the ducting needs to be much bigger, like what you see in Europe. 200 diameter ducting, or equivalent rectangular ducting, like the mega duct as it's called. A lot of the off-site manufacturing don't even allow room in the ceiling for 204 by 60 channel, because they're cutting down the sort of top hat arrangement of the ducting that sits inside it. So then you've got the spindle sitting in the airflow of the ducting, creating noise. People move into these lovely new buildings, they've never lived with heat recovery before, and all they can hear is this awful white noise from the drone of air movement. But yeah, I just think we need to allow more space for the equipment, allow more space in the ceiling for it, and carry out proper design and installation from cradle to grave.
Yeah. Okay. Yeah. Thank you. Thanks, Nathan.
Welcome.
So Nathan, I'm going to ask Bernard Hornung to unmute in a second. I'm going to just before read out a question from Richard Daniels, because I think that the two questions sort of are quite overlapping, and hopefully you'll agree. So Richard Daniels' question was, do we need an MOT equivalent for venting residential, I guess could be more general, multiple occupancy spaces, or even for the entire MEP system? So hold that question in your mind, and I'll ask Bernard if you'd like to ask your question. Shall I read you up, Bernard? Maybe he's had to leave.
Right, and I'm here. Thank you. Can you hear me?
Absolutely.
Right. So first of all, thank you very much indeed, Nathan. It's a very insightful summary of several of the challenges which we're all facing. And if it's any consolation to you, I, in my own industry, have found similar resistance. And I think the resistance is people being revealed, and people don't like to be ashamed. And when you reveal poor workmanship, and when people are ashamed by what's happened, of course, they get extremely sensitive, and they become very defensive. And there has been, unfortunately, this culture of covering up, and in many cases, physically covering up mistakes. And as technology advances, we can see more, we understand more, and much more is being revealed. So we are at this very difficult stage in the built environment when you have a group of like-minded people like the audience today, striving for excellence, knowing the solutions, knowing that, you know, everything we do is a good deed, and the more good deeds that we do each day will achieve the excellence that's required. But you do have this resistance, and you will come across it at every level, so from senior government ministers right the way down. And it's based on a fundamental of a very poor understanding. And I think that between us, we just have to educate people, like you've done so well today, and my magnificent presentation you've given us. But we mustn't lose heart. You know, I'm 65 years old, and I'm still at it. And I'm sure that I infuriate very many people. And I'm pleased I do, because the air we breathe is essential for life. And we've just gone through a pandemic, which was essentially an indoor air crisis. And we now have to address this. And what has been the Cinderella of our industry must stop being it. And ventilation and indoor air quality or indoor environmental quality must now be subject to post-occupancy verification. And just like we have fire inspections, we need to move towards ventilation inspections. Thank you.
I completely agree. They are intertwined, these two. So an MOT of your car is very much the same as a commissioning certificate with a ventilation system. At the time of testing, it passes or fails. There's nothing to say that the residents won't play around with the air valves or things might go haywire with the system. But when we get called back in and we see a lovely certificate with perfect airflows, and then we're running the unit at like 99% of its range, and we still can't get those flow rates, there's something very suspect in that reading. We put endoscope cameras up into the ceiling, flexible ducting, crush stuff, you name it, it's all there. Bernard, I like to use the word positive disruption. That come from Georgia Elliott Smith, if any of you know her. Yeah, positive disruption. We're fortunate enough now, 21 years of business, to actually turn around to clients and say, that's not right. And I think we're challenging our industry, and we're challenging our livelihood in a way, in the fact that some customers may turn away from us because we're issuing these non-conformances. They haven't got the time for it. They haven't got the people that they need to run the contract properly in the first place, I would imagine. So let alone when suddenly, oh Christ, I've got to now go back to, we issue it to our client, they've got to issue it to the main client client's got to deal with it and come back and report to them. Then you've got to have a meeting, and then it carries on. But all of the time, people within these blocks of flats or homes or offices or schools are breathing substandard air. They're in buildings that aren't safe for inhabitants because of the risk of fire and the spread of fire within the system. Councils are spending millions of pounds addressing fire doors and compartmentation sections with plasterboard and visually fire protection works. Go beyond that, you've got fire dampers that have never been touched since the day that they were installed and will not work in the event of a fire, which takes away the need for everything else. So there is change happening. As I mentioned, the Building Safety Act, I think, will force change, but it will need companies, I think, with courage and people with courage to stand up I hope there's lots of you on the call will today and say, this isn't right, we need change. And that's what we've got to push for collectively.
Well, thank you, and I totally agree with you. During the pandemic, our firm was asked to produce new technology, which we did. And the very people who asked us to produce it now wish they hadn't, because what we've done is revealed far too much and they just can't cope with the situation.
Mm.
And we developed a microscopic air leak detector. And we can detect air leaks in buildings as small as 0.06 millimeters, which is, narrower than a hair breadth. And when you get to this sort of level, when you're with, the National Physical Laboratory, and you discover the sophisticated algorithm which enables you to quantify air flow rate using very sophisticated algorithms. And suddenly you pair with technology which surprises everybody. Instead of, people saying positively, well done, our experience has been, wait a minute, this is a bit too good. It's coming a bit too early. We can't cope with this. And you're right. We've got to be strong enough to disrupt the industry and say, well, look, I'm sorry, but science has now enabled us to reach these dizzy heights, and we've done it, and you've got to accept that you're now going to come under pressure because we have the instruments that will reveal the truth. So thanks.
Thank you.
Thank you. So I want to give people a couple of minutes before they have to rush to the next meeting. Please look in the chat. Simon Corby would like to draw people's attention to the Buildings Performance Network and their newsletter. I like the spirit of Richard Daniels's comment. And there is one last question. Sam posted this, and so I'll read it. Just if you can respond to it quickly, Nathan, otherwise perhaps you can get in touch with him outside of this. He's questioning whether the Building Safety Act will really change anything with ventilation installation on new builds.
Yeah, I'm not on mute in my notes. So yes, it should. It's probably going to take a long time to come into play because I don't think many buildings actually fall under the new regs or indeed would fall into the Act. There's going to be further developments with different types of buildings, not just tall buildings that fall in, but we're treating them all the same at the moment. So it's with Part F, I think there should be a requirement for independent commissioning of systems, and that you shouldn't be able to use the same company more than X amount of times, almost to invigilate the work that you're doing. There are some fantastic, I've given the industry quite a bashing today, but there are some really, really good companies out there that are doing amazing work, amazing workmanship that don't need independent commissioning, but it just adds that extra value for your client when it is independently certified and signed off and handed back.
Well, yeah, I mean, we all wear a seatbelt all the time, and 99% of the time we don't need it, but you need it there all the time for the times that you do. Excellent. Well, thank you all for your questions. It's been a really lovely presentation from Nathan and a really great set of discussions. So thank you all. And